Hi, we're going to look at tree diagrams today. So we need to refer to the question and look out what it's asking us to do. This question is about soft toys, and we're interested in whether the toy splits open and whether it has poor stitching. First of all, let's look at the first thing, which is, does it have poor stitching? So I'm going to put P for poor stitching and not P for not poor stitching. The probability that it has poor stitching is 0.03. And so obviously the not poor stitching is 0.97. The probabilities on each pair of branches need to add to 1. Next, we'll look at the second thing, which is whether it'll split open. There are two options here, because the probability of it splitting open depends on whether it had poor stitching or not. If it has poor stitching, so that's this branch up here, then the probability of it splitting is 0.7. And so it's 0.3 for not splitting. If the toy has good stitching or not poor stitching, the probability of it splitting is 0.02. And the probability of it staying together then, not splitting, is 0.98. Now we should find the probabilities of the combined events. So walking along the arms of the stitching of the probabilities, if we want to find the probability that they have poor stitching and then split, we need to multiply those results together. So 0.03 times 0.07 is 0.021. 0.03 times 0.03. 0.03 times 0.3 is 0.009. 0.97 times 0.02. Do that in my head quickly. 0.0194. And finally, the probability of good stitching and not splitting is 0.9506. Okay, good. That's answered that question completely. Next thing would be questions like, what's the probability of it splitting? So to work out the probability of the thing splitting, we would look for the probability of it having poor stitching and splitting, and the probability of it having good stitching and splitting, add them together. Okay, if you go along the arms of the tree diagram, you times. If you want to add, if you want to combine events at the end, you add them. Okay, let me know if you need some more help.